Hello, good morning, viewers. This is the problem I posted on my Facebook page. Though most of the solutions were correct, but with a very wrong conclusion, because it is not solving a problem that matters. What matters is, does the solution really satisfy the original problem? And that is what we are going to look onto in this tutorial. This is a right angle triangle with some lengths. We have the hypotenuse, which is the longest side, as x plus 2, and we have the other two sides, x minus 7 and x. Applying Pythagoras rule here, it says that the hypotenuse, which is the longest side, AC squared, will be equal to AB also squared, then plus BC squared. By substitution, AC is x plus 2, so we have x plus 2 all squared, and this is equal to AB is x, so we have x squared, then plus BC is x minus 7 also squared. X plus 2 squared is the same thing as x squared plus 4x plus 4. And to the right hand side, we still have x squared here. And if you expand x minus 2 squared, you're going to get x squared minus 14x plus 49. Now let us bring everything to one side. To avoid getting negative x squared, let us take times to the left hand side to the right hand side. To the right hand side, you can see x squared plus x squared is 2x squared. So let me write that first. We have 2x squared. If you take this one to the right, it becomes negative. So we have negative x squared. Then we have a negative 14x. Negative 14x. This is positive. To the right, it becomes negative. So we have negative 4x. And we have 49 here. Plus 49. If this crosses over, it becomes negative 4. Now we can set this to be equal to 0. 2x squared minus x squared is single x squared. Minus 14x minus 4x is minus 18x. And 49 minus 4 is 45. And this is equal to 0. This is a quadratic equation that can be solved by factorization. We're going to think of two numbers, which when we multiply them together, we get positive 45. And when added up together, we have negative 18. The numbers are negative 3, negative 15. And if you set each of these factors to be equal to 0, the first factor x will be equal to 3, and the second one x will be equal to 15. And this is exactly how most people solve the problem. But the question is, do this solution really satisfy our original problem? Let us test. If x is equal to 3, you can see that x plus 3, here we have 5, here we have 3, and x minus 7, here we have negative 4. And there is no way we can have a negative length. Therefore, x equal to 3 will never be our solution. So what if x is equal to 15? If x is equal to 15, you can see here 15 plus 2 is 17. Here we have 15. And here 15 minus 7 is 8. You can see all the lengths are now positive. Therefore, we are going to consider x equal to 15 as our solution. And we are going to discard this. And hence x equal to 15. And this comes to the end of our tutorial. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel.